day everyone, so today we're gonna solve a problem in the chapter 6 of thermodynamics. A 4-cylinder, 2-stroke, 2.4 liters diesel engine that operates on an ideal diesel cycle has a compression ratio of 17 and cutoff ratio of 2.2. Air is at 55 degrees Celsius and 97 kilopascal of compression process. Determine how much power the engine will deliver at 1,500 revolution per minute. So, as you can see here, I already put the given and in temperature at state 1, so it is 55 degrees Celsius added by 273, this becomes 328 Kelvin. And the formula for your power is equals to number of revolution times work. So now, let's identify the Cp, the Cv, the R, and the K of the air. So the Cp, it is the specific heat in constant pressure and the Cv, it is the specific heat in constant volume. So here you can see that it's constant in its gas constant, or R, is 0.2870 kilojoules per kilogram Kelvin, and its Cp is 1.005 kilojoules per kilogram Kelvin, and its Cv is 0.718 kilojoules per kilogram Kelvin, and its K is 1.4. So let's solve for the temperature in the process 1 to 2, where it is in the isentropic compression. So temperature at state 2 is equals to temperature at state 1 multiplied to the V sub 1 over V sub 2 raised to K minus 1. So the V sub 1 over V sub 2, it is actually the formula to get the compression ratio. Therefore, the V sub 1 over V sub 2 becomes compression ratio, and let's just plug in their value. Therefore, we got 1019 Kelvin. And let's proceed to the process 2 to 3, where P is constant heat addition. So T sub 3 is equals to T sub 2 multiplied to the V sub 3 over V sub 2. So temperature at the state 3 is equals to temperature at state 2. So and multiply to the cutoff ratio. And then this becomes or by multiplying them or multiplying the value, we got 2241.8 Kelvin. So now let's gonna solve for the process 3 to 4 at the isentropic expansion. So the temperature at state 4 is equals to temperature at state 3 over V sub 3 over V sub 4 raised to K minus 1. So the formula to get the V sub 3, or the volume at state 3, is cutoff ratio multiplied to the volume at state 2. So the V sub 2 over V sub 4, it is also equivalent to the V sub 1 over V sub 2. Therefore, this becomes the compression ratio. Therefore, it becomes T sub 3 multiplied to the cutoff ratio over the compression ratio multiplied to the K minus 1. So plug in their value, we got 989 Kelvin. So now let's gonna solve for the mass. So mass is equals to pressure 1 P sub 1 over R T sub 1. So plug in their value, and we got 2.473 times 10 raised to negative 3 kilogram. And the formula to get the work net output is equals to heat input minus heat output. So to get or to solve for the Q in, we must multiply the mass, the Cp, and the temperature at state 3 minus to the temperature at state 2. Then plug in their value. The heat input is 3.038 kilojoules. And let's solve for the Q out. Q out is equals to mass multiplied to the Cv, or the specific heat in constant volume, and quantity T, or temperature at state 4 minus to the temperature at state 1. So plug in their value. Therefore, we got 1.174 kilojoules. Since we already got the value of the Q in and the Q out are the heat input and heat output, therefore we will subtract them. And we got work net output is equals to 1.864 kilojoules per revolution. So now let's solve for the power. So power is equals to number of revolution times to the work net output. So the revolution is 1500 revolution per minute. So since 1 minute is equivalent to 60 seconds, therefore this become like this and multiplied it to the work, which is 1.864 kilojoules per revolution. Therefore the power is 46.6 kilowatts. So this is the power that the engine will deliver at the 1500 revolution per minute. And I hope that you learned something from it. Goodbye and thank you everyone.